I'll get started while he's going down just to see if anybody else is coming in. First of all, my name is Pete. I am the AOS Systems Administrator. I got my bachelor's degree in meteorology here in 1988. I'm guessing, is that before most of you were born? That's frightening. So anyways, yeah, I got a bachelor's in 88, a master's degree in atmospheric science in 1992, and I've been doing this job, the computer systems administrator, since 95. So I've been working with Unix since probably the late 80s. I'm trying to think, the first time I sat down at a Unix workstation was probably, early 90s, I'm guessing. So if some of this stuff seems kind of foreign, and I'm talking about it like it's my native language I've been working with for a really long time, it does take a while to get the hang of it. And I don't really go into a whole lot of depth in anything tonight. I sort of just give you enough to be able to find your way around. And I'm here as a resource if you have any questions along the road. If something's not working or you want to know how to do something, that's why I'm here. So I like to keep this kind of open. If a question comes up along the way, stop me. If something's not clear, stop me. Nobody else?
No.
Awesome. Well, maybe not awesome, but so yeah, if a question comes up along the way or during the course of it, something that there's a question that you've kind of been wondering if you've used Unix at all before and something doesn't make sense, let's talk about that tonight, or something in your research that you've always wished you could make happen, and you should be able to, but you don't know how, whatever, anything like that. So anyways, I'm going to talk for a few minutes just about the computers in here, and then we'll go through Unix, and at the very end I'll talk about VI, which is an editor. If you're not interested in VI, I won't be disappointed if you leave. If you've got places to be, I'll try to be done by 9, but if you've got places to be and you don't, if you're not interested in VI, that's okay. It's a really useful editor, and it's on any Unix machine that you come in contact with. Emacs, NEdit, some of the other editors that you've used aren't necessarily always on there, so it's a good thing to know, but there's a bit of a learning curve, and like I said, I won't feel bad if everybody gets up and heads out at that point. So real quick, the computers in here, there's 15 of them. They're dual boot Windows and Linux. The default usually during the school year is Linux. So when you first walk in here, you're going to see a red background on it, and that is the Linux operating system. If you need to do something in Windows, you can reboot them, and I'll show you in just a second. On the startup screen, just start hitting the down arrow, and the bottommost entry on there is going to be a Windows entry. It'll boot up in Windows 10. Your logins, if you have a real login in here, does not work on Windows. That only works on Linux. As of right now, there's only a guest AOS account that uses the same password as the one on Linux, which I'm not going to say out loud because of the video recording, but it's the same one. It's got Microsoft Office. I think I got another slide with some of what's on there. A couple of things about it here. It really helps if you log off when you're done. I'm guessing all of you probably know how to log off with Windows. You go click the little start thing and log off. I'll show you how to log off on Linux. It is possible to stay logged in and have multiple people log in, but it can bog the machines down. So I appreciate it if when you're done, log off. Older versions of Unix, if somebody stayed logged in, nobody else could get on to use it, which was kind of a bummer if a class came in here and wanted to use it. So that's another reason, although that seems to happen less now. The login manager is a little smarter and lets more than one person do that. So you all saw this when you first walked in, right? That's the Linux login screen of my own design, the little AOS logo up there. When you first log in, username and password, which is either the username and password that I gave you or the guest one if you don't have one. If you're going to be working in here a lot, it makes sense to talk to me and get a real account in here. The AOS user is specific to each individual machine. So if you log in as the AOS user on Windows or Linux, and you do anything, you save any images or whatever, you have to go back on that same machine if you want to get back at them later. That is not the case with the real accounts. If I set up a real account for you for classes, those accounts are stored on a server down the hall, and it doesn't matter which of these machines you log into, you'll always have access to that same data. Which is another reason why you might want to log off when you're done, because if you're logged onto one machine and you run a web browser, and then later you log into another machine and the browser is still, he's nodding his head because it happened to him probably. It won't let you. It'll come up and say, sorry, you're already running this on another machine, and then you have to go, oh man, what machine was I logged into? I don't remember. Then you come and bug me, and I give you a hard time about it. But anyways, that's where you log in. Also in the upper right-hand corner here, there's sort of like a power-looking button. That is how you can restart, and you'll see a similar thing when you're actually logged in. If you restart the machine, you're going to get a screen that looks a lot like this. It doesn't have a little blue background in the background, and we're no longer running Windows XP because that's ancient. But I thought that was a pretty clean graphic. You'll see a number of lines having to do with Linux, and the bottom one is Windows. So, like I said, by default, it's going to boot into Linux. If you want to boot into Windows, hit the down arrow key. You've got about 10 seconds or so on these machines to do that. That'll boot into Windows, and then of course everybody knows what Windows looks like. We talked about that already. This is the software that I have available on the Windows side if you need access to Microsoft Office. There's also LibreOffice on there. A bunch of Adobe programs if you need Adobe Acrobat or Photoshop or Illustrator. Number of web browsers. Some of you may be in the, I think it's the 425 class that's using the EdGCM. That's installed on here as well. Some of the machines have Hydra and some other software on there too. And if there is specific software that you need to run on Windows and it's not in here, let me know and I can probably, assuming it's not like super expensive, I can probably make that happen. That's a Windows 7 reboot, but it looks the same. You basically go to the start menu and do a restart, and it will automatically come up in Linux. There's one caveat to that. These machines in the front two rows and the machine closest to the Windows in the third row, there's something about the Windows network driver that messes the network card up for Linux. So if you just restart from Windows back into Linux, when it comes up, it won't be able to talk to the network and no one will be able to log in because all of the accounts are on the network. You actually have to shut the machines down after you run Windows, power it off, and then turn it back on. When it comes up, it'll come up in Linux and it'll work correctly. So if you come in and one of the machines in the front is in Linux but it won't let you log in, that's probably what happened. Just hold the power button and it'll shut off. Hit the power button again and it'll come back up. So the AOS user works for both Windows and Linux. Like I said, the data that you save is only on that particular machine if you're using the AOS account. If you have a real account, it will be on the server and you'll be able to access it on any of these machines. Also, there's 4 machines in 1443 next to my office that are on the same network and set up the same way. So if you need to do some work and there's a class going on in here or it's full or whatever, you can go work in there. There's also a couple of remote login machines that I'll talk about later that also, when you log into those, all that same data is available there. So when you log into Linux, you get a desktop that looks like that. There's a bunch of applications available from the menus in the upper left-hand corner. I'm really not going to talk about the GUI interface at all tonight because everybody's used Windows or a Mac and it's pretty intuitive. You can kind of figure it out. If you have questions about it, by all means hit me up. But I'm mostly going to talk about the stuff that you do in the command line or when you remotely log into a machine because that's a little bit less intuitive to people, I think. So yeah, more stuff. There's a couple of ways to open a terminal window if you want to grab one. There's an icon, there should be an icon near the top in the upper left that looks sort of like a terminal window. Or you can go under Applications, under System Tools, Terminal, and that should open up a terminal. And you can open up more than one if you want. You can have a dozen of them or however many you want to go on there. That's how you get at that. When you're done, I think this is still accurate. Under the system menu, there's a logout in your username. There might be something up in the upper right-hand corner too where you can go and log out. I can't remember, this version of the OS might have it in the upper right. If you can't figure out how to log off, let me know and I can show you. But I would appreciate it when you're all done, just log off. How many times have I said that now? Any questions about all this stuff? Windows, Linux, how to get back and forth, what's going on? All that stuff pretty much just applies to this lab, so. Okay, we'll move on. We'll go through Unix. I'm going to talk real quick about operating systems, real quick about history. We'll go over basics of a Unix session, getting logged in. I'm going to talk a little bit in depth about the Unix file system because that tends to throw a lot of people off. And if you understand how it's laid out and some of the aspects of it, it's a little bit less mysterious, some of the things that happen and that you do. We'll talk about working with files and directories and various commands that you can do, setting up an environment and different environment variables. We'll talk about the shell a little bit also. We'll talk a little bit about some compilers, less about email and text processing and image processing, and at the very end we'll talk about the VI. So that's sort of what we're going to talk about tonight. This used to be a 4-hour class. I used to do 2 hours on Tuesday and 2 hours on Thursday, and I found that the drop-off of people that came back on Thursday was really high. So I tried to compress it, and it goes by really fast, and you'll probably walk out of here feeling like you got hit in the head with a hammer, just all this stuff, and you'll be like, I don't know what I just learned. That's why I'm giving you copies of the handouts, and that's why I'm here. Probably most of this stuff you won't remember tonight, but like sometime you'll be working in class, or you'll be logged into a machine, you'll be doing something, you'll be like, oh yeah, I remember Pete said something about that, and then you can go back and look in there or ask me later or whatever. So that's basically what this is. Try to get you so that it's not quite so foreign, and hopefully remember some of it. Okay, so everybody I guess has either used Windows or a Mac in here. Has anybody not? I would be very surprised if that were the case. Has anybody used Unix or Linux before? A couple of people have, just a little bit. Good, you got a head start. So everybody knows the operating system is the main program on the computer that basically does stuff on it, right? All the other programs run under Windows or OS 10 or Unix or Linux or iOS or Android on a phone. So Unix and Linux are basically similar. Unix has been around longer than I've been here. I guess it was, okay. So I was born in '66, so I'm actually 3 years older apparently than Unix, which I guess it makes me feel old, but it's been around forever. It was written by computer programmers for computer programmers, and there's basically what I want you to get off of this slide is there's two kind of main variants out there, and they're sort of kind of blended together now. Linux, which is Linux is actually not Unix, but it's very similar. Unix actually is licensed by AT&T, or I don't know who it is now, but you actually have to pay a licensing fee to install Unix on a computer. But Linux, the main core program was written by a guy called Linus Torvalds in the early 90s. And it was basically written to do what Unix does, but without any Unix code, and so you can install it for free. It's all open source, all of the code that's on there, all the programs that you run, basically do the same things that Unix does, but it's none of the same code and it's all free. So you can install it pretty much wherever you want. As I said, there's pretty much two main variants of Unix. One of them is called System 5, and there's just a couple of examples on there of the various operating systems that typically are System 5. The other one is BSD, and the main place where that comes into play is a lot of the options for the commands are different between the two. And you can usually figure out what flavor of Unix you're on based on what options the different commands work. Linux tends to be kind of a combination of the two. And from my experience, most of the command arguments from either of them tend to work on Linux. So here's your history of Unix. It's been around forever. It was written a long time. It was written by computers for computer programs, so pretty much everything is an abbreviation, because computer programmers are typing all the time, and the less they have to type, the better. So it's mostly lowercase abbreviations for the commands, and everything is case sensitive, so keep that in mind, that capital letters and lowercase letters matter. Okay, let's see, I changed the order of this today. The shell is basically what you see when you first log in, when you open a terminal window, or when you remotely log in. The two original shells that came with Linux were the Bourne shell, which is referred to as SH, and the C shell, which kind of has more like C programming syntax, and that's CSH. People have improved on those and added some other features that didn't exist in the original shells, but they basically use the same syntax. The TC shell is an enhanced version of the C shell. The corn shell and the born again shell are enhanced versions of what was originally the born shell. In this classroom, I've got all of your accounts set up to use the TC shell. And the main thing is just, again, it's differences in the way that you do things, differences in the way you set variables, differences in the way that you bring up your command history, differences in the way you can do looping and some other more advanced stuff in the shell. I think that TC shell tends to be a little bit friendlier if you're logging in and doing things interactively, whereas the born shell or the born again shell tends to be a little friendlier for scripting. That's just my personal experience. I'm not sure exactly. I mean, the bash born shell, if you have a Mac and you open a terminal window, that is the born shell. I'm sorry, the born again shell, bash. So as I go through the talk tonight, I'm going to mostly be talking about TC shell syntax, since that's what we typically use in here. Places where it varies from bash, in some places I tend to point that out, and in others I don't, but if there's any questions that you have about bash, you can let me know as well. So basically the shell is what you get when you first log in. Some of the stuff that's provided by the shell, when you do log in, you can create an environment that meets your needs. You can set environment variables that change the way different programs behave or tells them where to find data files or things like that. You can use the shell to write scripts or batch files, which are basically as if you had typed a bunch of commands in at the screen, but just having to run one command to do all of that. Or if you find yourself running the same set of commands over and over and over again, you can make it a lot simpler on yourself by just making a script on that. You can define command aliases, which are short versions of more complicated commands, and we'll talk about that later. It does keep a command history, so you can go back and repeat or edit commands that you've already used. One nice thing, you can automatically complete the command line, which works on files or command names or usernames or pretty much anything. If you're trying to do something and you type enough of whatever it is you're trying to do to be unique, you can hit the tab key and it'll complete that for you, or it'll give you an options from which to complete it. And then on the command line, you can use the arrow keys generally to edit. If you make a mistake or if you've got a previous command you want to modify it slightly. We'll show some of that later. Okay, so let's pretend that you're not actually in here logging in through the graphical interface. Let's pretend that you logged in remotely. You're going to log in with your username and a password. It's a little bit different if you're logging with Secure Shell, and I talk about that later. This is the time when I have to give the password speech. Okay, so when I first set you up with an account, I gave you a password, and it was semi-complex. It's a good idea to have a password that's hard to guess. And what hard to guess means has changed over the years. Computers have gotten so fast these days that you can pretty much run a dictionary attack against a password file and guess an 8-character password in a weekend. I mean, it's really not that hard. So in the olden days, I would suggest coming up with a password that's based on a sentence that you can remember. Pick the first letter of each word in the sentence and maybe change it, a couple of them to capitals or a couple of them to $signs. So for example, this is my password at work with a $sign on it, and you pick the first letter, and it's easier for you to remember, but not easy to guess. But it is pretty short. The advice over the last couple of years has changed. Now it makes more sense to actually use the big phrase, right? So I hate having to change my password every 3 weeks, and then when they make you change it 3 weeks later, you make it 4 weeks or whatever. Is a good password because it's easy for you to remember, but it's kind of hard to guess, right? I mean, if you just took a dictionary attack and tried to guess a 40-character password, it would take a while. And the reason why you want to have a good password is because we don't want to get hacked into, right? I mean, I hear from professors all the time, well, I've got weather data. Who's going to steal that? What do I care if they break into my account? But the thing is, we have high-powered computers on a really fast network with a lot of storage. And I have had in the past people hack into our machines and store, pirate software, or porn, or whatever. And the other thing too, if you're gonna go hack into like a government computer, if you were just sitting at home and you just, started hacking away and trying to get into a government computer, probably over the weekend, the men in black would be at your front door saying, hey, what's going on? What are you doing? But if you hack into my computer that I haven't logged into in half a year because all it's doing is generating maps for the web, and then from there, you hack into a computer at Berkeley, because they've got one that's doing the same thing, and then they hack into one in Miami, and then pretty soon you're like 8 or 10 computers down the line. By the time the men in black find their way through all these computers back to you, the logs are probably gone, right? So it's just generally a good idea to try to protect the resources. So having a good password is important. Any questions on any of this stuff so far?
I have a question.
Yeah.
So when it comes to like having a good password for computers that we have, personal computers and like office computers here, how often should we be changing those? Or should we be changing them in our?
That's debatable. I mean, if you're changing it so often that you have to write it on a Post-it note and stick it underneath your keyboard, that's maybe not as secure as having a really long password and being able to remember it. I've got some machines that I haven't changed the password on in a long time. I think, do they force you to change your password on NetIDs anymore on the campus? I know they're going to be going to two-factor authentication pretty soon. They're starting with staff, and then by next year everybody will be on it. So it'll be a username and a password, and either an app on your phone or a token that you have to type in a number that changes all the time, which makes it a lot more secure. So yeah, I'm not sure there's a really good answer. It's not a bad thing to change your password once in a while, and it's a good thing to not have the same password on a whole lot of machines, right? I mean, Facebook's been hacked into, Google's been hacked into, there's been a lot of data breaches lately, and if you're using the same password everywhere, even on a system that didn't get hacked into, they might know your password, which I remember reading a story about a guy, somebody hacked into his iCloud account and deleted his history, like all his pictures, all his music, everything was like gone within like an hour. Like he lost everything. And he was like, yeah, multi-factor probably would have prevented that. I'm encouraging that. So anyways. Okay, so another thing about Unix that's maybe different from what you're used to on Windows or whatever is you can log into the machine more than once, as you found out already. You can log in multiple times, and you can be logged in from different places all into the same machine, or you can have multiple windows open on a single desktop all to the same machine. And many people can all log into the machine at once too. It's a multi-user operating system, which is important. You do have to kind of keep track of resources. Sometimes you'll run a program and it takes down the machine, and that affects other people. Probably more of an issue for research groups than in here, because usually there's only one person logged in and doing stuff in here. But anyways, wow, I'm prognostic here. And many people can be logged in at the same time. I guess I said that already. We do have 3 remote login machines. These machines in here, when they're running Unix, or when they're running, I'm going to say Unix and Linux interchangeably, even though they're not the same thing, but effectively. The machines that are in here are remote log-inable. I don't know if that's a word, but you can remotely log into these machines when they're running Linux. However, I recommend against it because they're dual boot, and at any time somebody could walk in here and boot into Windows, at which point anything you were working on could be lost, or in the middle of something that doesn't get saved. Because of that possibility, I do have 3 remote access machines, Cat 3, Cat 4, and Cat 5. You'll notice, or maybe you don't notice, all the machines in here are named after classic hurricanes. The next set of machines that I've got that are going to be coming in here are named after 2018 hurricanes. That'll be interesting. But anyways, that's where the Cat 3, Cat 4, and Cat 5 come from. I used to have one called Cat 6 because it was kind of a offshoot machine. It just wasn't like a normal machine, but with all the fake news accusations going around, I didn't want to, there is no Cat 6 hurricane, and I don't want to be accused of fake news, so I got rid of it. But anyways, Cat 3, Cat 4, and Cat 5, if you log into those using the same username and password that you do in here, you can access your data and do work from home. A lot of the graphical stuff that you run in here, you can run over the network. If you have what's called an X server on your PC at home or on your Mac, and you have to forward the X Windows graphics through that, and if you need help doing that, I can show you how to do that. Caveat, it will be quite a bit slower running it, especially depending on what your network connection is like. There's a lot of back and forth data transfer running X Windows programs. So you can do it, you can run Genpack, you can run other X Windows programs remotely at home, but they'll be a lot slower than what you used to up here on campus. For Windows, if you want to remotely log in, there's a utility available on the campus software library, I think it is, called Secure CRT. It's a licensed piece of software that you can use, and it makes it really easy to set up logging into different machines, and it's tabbed, so you can have a bunch of different connections open in the same window. It forwards X Windows graphics. There's also a free SSH client called PuTTY that's out there. A lot of people prefer that. Either one is fine. And I generally recommend a program called Xming for an X server on a PC. I do have, at the way end on the last page of the handout, there's an X Windows link that I think is still valid and works. That sort of goes through the instructions of how to get things up, to set it up if you want to remotely log on and do X Windows stuff from your laptop. Or you can see me and I can help you get set up too. If you're on a Mac or on another Linux machine, you can SSH and remotely connect into another machine from the terminal window. The syntax for how to do that is on here. SSH and then your username at whatever the remote machine is, so that'd be like cat5.aos.wis.edu or something like that. To forward the X Windows traffic on from a Mac, you need to use the -Y option. From a Linux machine, usually you have to use a X option. The difference between those two, they both forward X Windows traffic, but one of them apparently is more secure than the other. The Macs, you have to use a Y. I've found that generally that doesn't work on a Linux. If you're going from a Linux machine to a Linux machine, use a -X instead. And on a Mac, you need, I don't have this on here, but you have to have an X server called X Quartz. That's the X server for a Mac, and I think there's sort of they used to distribute X Windows with OS 10, they don't anymore. I think there's an X Windows sort of looking thing in the utilities folder, that if you click on it, it says, hey, sorry, we don't do this anymore, go here and get it from wherever. But if you just search on X Quartz, you should be able to find that. And again, I'm happy to help anybody get that set up and working if you need help. So when you log in remotely to a Unix machine, it starts in what's called your home directory. That's where you'll be in the Unix file system. We'll talk a little bit more about that in a few minutes when I talk about the file system, in terms of where you end up and where other things are related to that. When you're done, if you're remotely logged in, you can type log out, or you can type exit, or you can type Control-D. Usually any of those will work, or at least one of them will. If you're logged in here, again, you have to go up on that top menu bar somewhere and log out to actually get logged out. Just closing all the windows and leaving it does not actually log you out, so heads up on that. Other versions of Unix, there are other ways of getting out of it. Usually if you try clicking some of the mouse buttons in the background or look at some of the menus, you can usually find it. As I've said about 6 times already, make sure you're logged out. If you stay logged in, other people could come in and start doing things. They could delete your files, they could send nasty emails as you, I mean, all kinds of bad things can happen. So it's a good idea to log out. Okay. I don't have a good recommendation on how often to change your password, but I can tell you how to do it. I do recommend, when I first set up your account in here, I usually make it something like, yeah.
So if you just like let it freeze out in a timeout, and it comes up and it'll say your name, you click switch user, so you're still logged in then?
Yep.
Okay.
Yep.
So you're actually okay.
Yeah, and that does work on this version of Linux. You can, and if you come in here and it says switch user, it'll give you a login screen. You can log in and do your stuff, and the other person will still be logged in. I recommend not doing that, not leaving it logged in. I mean, if you're going out to get a soda, or you're just going out to get lunch or something, and you're in the middle of something, go ahead and leave it logged in, but if you're headed out for the day, I'd appreciate it if you could log out. Okay, so when I first set up your account in here, I set a specific default password, and it's probably something like fall 2018 or whatever, something along those lines with some Greek characters. I do ask that you change that. I've tried setting up in here, forcing new passwords, and that caused all kinds of problems, so I usually don't do that, but I just ask people, please change your passwords. To change your password from the terminal, you can type PASSWD. It'll ask for your current password, then it'll ask for a new one, and it'll enforce some rules on that. And then it'll ask for your new one again to make sure you typed it right. And if you didn't type it the same both times, it'll ask you to do it again. If you did type it the same, then it'll change your password, and from then on, you use your new password. If you forget what your password is, you're working here for a semester or two, and then you go home for the summer, and you come back next fall, and you don't remember what your password is, I cannot tell you what that is. I can't go in and decode your password. The way it works is that the password gets turned into a hash when you type it, and it compares it with whatever's in the password file. And if they match, then it lets you log in. However, as the systems administrator, I can change your password. So if you, in this department, if you forget what your password is, come and see me and I can change it for you. If you're working in some other Linux machine somewhere else, you'd have to talk to their systems people to have them do that. Just a couple of commands about user IDs. Sometimes, especially if I'm logged in, I'll use the SU command to switch to a different user right while I'm logged in, and maybe I'll forget who I am. If you don't know who you are, you can type the ID command, and it will tell you your username, and I think it tells you what group you are also. There's a concept, I sent this out on Twitter and Facebook earlier, there's three people in the world, three kinds of people in the world, at least according to Linux. There's you, there's your group, and there's everybody else. We'll talk about that a little bit later. The second one of those, your group, if you type groups, it should tell you what groups you are a member of. And the first one is probably your default group, whatever group you're assigned to when you first log in. And then there's a special user that always exists on a Unix machine. Even on Macs, but I think they have it disabled, but it's there. A user named root, which is the administrative user. It's like administrator on a Windows machine, or having administrative user on a Mac. Root is often called super user. It basically has all permissions on anybody. It can look at anybody's files. It can do anything. It can delete things. It's wise to not do things as root because if, for example, if you browse to an infected website and there's malware that gets installed, it's much more likely to do damage if you're logged in as root because it can change system files as opposed to you. That makes sense on Windows and Mac for that matter, but it's also possible to accidentally cause damage as root, which I'll tell a story about Professor Morgan at some point. You can actually delete your operating system, which he did. Yeah, that was funny. But anyways, every Unix system has a root user. If you install it on your like for example, your laptop, you can have access to root. In here, I have access to root, and like I said, basically they can see anything, do anything. They're like the Uber user. They can do whatever they want. Okay, so I'm going to talk about the Unix. Any questions so far? There's been a couple. Anything else? Everything's sort of semi-clear so far. Okay. The Unix file system. Everything. It never really occurred to me, but Michael and Professor Morgan mentioned this to me the other day. Everything on Unix is a file. It kind of actually is. And the file system is how it keeps track of all that stuff. So there's different types of files that you'll encounter on the Unix system. There's ordinary files, which is like what you'd normally think of as a file, right? Like a picture or a song or a text, Word document, something like that. There are special files called directories, which is like a folder on Windows or on Mac where you have a folder and it's got a bunch of files inside of it. So basically, a directory is a special file that holds links to a bunch of other files, and you can use them to keep things organized, or not. Some people don't, but it makes it a lot easier to keep track of stuff. There are some special files, usually under the /dev directory, we'll talk about that in a little bit, used to represent physical pieces of the computer, disks, the mouse, the monitor, the graphics card, memory, stuff like that. Printers, and then there are special files called pipes, which a pipe is basically an on-the-fly created temporary file that's used to hold the output from one command intended to be used as input to another command. You'll find that a lot of Unix commands are fairly simple and they're very good at doing like one thing or a few things. But you can make really complex commands that do really complicated stuff by chaining them together and doing different aspects along the way. We'll talk a little bit about that later when we talk about aliases. So basically everything is a file. Every directory on a Unix file system has two files in it when you first create it. So when you first make a new directory, it automatically has these in it. One of them, I'm going to refer to it as .. And that is a special directory that always refers to the directory one level above wherever you're at. So if you're in a directory and you want to go up a level, you can say change directory ... and it'll go up a directory. And you can use that in paths as well. I'll show you some examples of what I mean by that in a minute or two. But it's basically a special directory that refers to the one right above wherever you're at. The second directory that always exists in a directory when you create it is a .. directory, which is a special directory that refers to whatever directory you currently happen to be in. And I will show at least one example of where you might use that later on. So those two directories will always exist. Any file or directory that starts with a period is a hidden file, so if you create a directory and you go in that directory and you do a directory listing, you're not going to see them right away, but they're there. There's an option to the directory listing command that will show the hidden directories and files as well, and we'll talk about that when we get there. But so those are always there. The Unix file system is organized as a hierarchy or like a tree, starting with a forward leading slash, like not a DOS or Windows slash. It's not like a backward slash like that. It's a forward spacing slash, like a divide sign. The forward slash is kind of similar to my computer on Windows, or like the C drive maybe, or on a Mac, maybe the desktop or the Finder. It's sort of like everything else is underneath that, is stored underneath that leading slash. So that's the base of the tree. Here is an example just laid out of a sort of, not an entire file system, but pieces of it. So, and along with the path name that points to each of these different directories. So this leading slash is the sort of beginning of the file system. You might have a directory in there called /bin, which is a directory called bin that's right underneath the root file system. You can refer to that with /bin. You might have, in the case in here, /home1, and then some subdirectories underneath that. Underneath /home1, I've got a class directory, and then I've got directories based on when I set up your account, so it'd be fall 18 for people that I just set up for now. And then underneath there would be maybe a directory with your username. So for example, here's my home directory in this classroom. It's /home1/class/fall06/poker. And that would be my home directory. When I first log into one of these machines, that's where I am, in that part of the directory tree. And then there's some other directories as well. Typically on a Unix machine, like if you install Ubuntu or something on your laptop, usually home directories are put in the /home directory. So it'd be /home/AOS or /home/your username or whatever. And then there's some other directories on here. /dev is where those special files live, like the disk files and other things like that. And I think I talk a little bit more about this later. Etc. is where a lot of system configuration stuff usually goes. /lib is typically shared libraries that are sort of common pieces of code among all that are used by a bunch of different programs. /tmp is a temporary directory. For example, if you open a file in an editor, either VI or Emacs, a lot of times it doesn't actively change the file that you open. It opens a temporary copy of that file. Then it makes the changes to the copy of the file, usually keeps it in the temporary directory, so it like opens another copy of the file in the temporary directory, makes the changes to that, and if you want to save it, then it copies it back to the original file. And if you want to abort, you can just give up and it just deletes it. And doesn't actually change the file until you save it. And then /sbin is another directory in which programs would live, and I'll talk a little bit more about some of these different directories on the upcoming slides. Any questions on that? Okay, so when you first log in, you're in your home directory. Typically they're under /home. In this classroom, they're going to be under /home1/class/something, probably fall, whatever directory I set up your account, and then your username. If you open a terminal, the way I showed you earlier, if you go from the top menu bar, you go through the menus and get to it, it will open a terminal, and that terminal will drop you in your home directory. If you have an icon on your desktop that looks like a terminal, and you open a terminal that way, it actually opens it in the desktop folder, the desktop directory in your home directory. It took me a while to figure that out because it was very confusing. People would start a terminal from an icon on their desktop and do a bunch of stuff and save things, and then they would start a terminal from like the top menu bar later, and none of that stuff was there because it was all in the desktop folder. It was confusing. I don't know if all of you have a terminal on your desktop, but if you do, just be aware when you start it that way, it's going to start in the desktop folder rather than in your home directory. Okay, there's a concept of a current working directory. When you first log into the machine, it's going to drop you in your home directory, but you can do various things to change what directory you're in. And if you've been working for a while, you might not remember what directory you're in, and you can use the command pwd, which will print the working directory. That's what that stands for. That will tell you what directory that you're in. Yes?
What does tornado mean?
What does tornado mean? Okay, so remember I mentioned that the AOS account is local to each of the machines in here, but your account is on the server. So the server is actually named Tornado. That's the name of the machine on which all of the networked home directories in here are on. And it doesn't have to be called Tornado on here, but I do that so that when so on the file system, I know that those directories are on the machine called Tornado. That's just sort of a convention that I use, where so you can actually take file systems on one machine and using a protocol called NFS, Network File System, connect them to another machine and access them as if they were just directly connected to the other machine. There's other ways of doing that besides NFS, but that's what we're using here. It's just easier for me to remember that a drive is physically attached to a different machine if I put the name of the machine in the path of the file system of where it's connected. Does that make sense?
Yeah.
So yeah, that actually your home directory is under /tornado/home1/whatever. But I have some symbolic links, which I think I talk about those a little later, that make it look like /home1 is actually, it basically is a pointer that points to tornado/home1. Does that make sense? If it doesn't make sense, it probably doesn't matter. That's okay. But anyway, so that's where that is. Okay, so pwd will tell you what directory you're in. Is that how you figured out the tornado thing? You're in your home directory and it said /tornado?
Yeah.
It probably did that because, like I said, it's a symbolic link that points to the tornado one. I'm going to talk a little bit about absolute versus relative path names. There are a lot of different ways to refer to any given file on the system. The most complete way of referring to a file is to give it an absolute path name, which means it starts with that leading slash and gives all of the directories all the way through the file system until you get to the file that you're talking about. So for example, in this one, I've got a file, let's say I'm logged in to my home directory, which is that fall 18 poker one, And in my home directory, I make a directory called dir1, and in that directory, I create a file called file1. Okay, the actual full path name that points to that whole thing is /home1/class/fall18/poker/dir1/file1. So that like goes through all the different directories in the file system to my home directory, and then the directory in there, and then the file inside that directory. If I'm in my home directory, I can also, so for example, my current working directory, right, I just logged in and I'm dropped in my home directory. I can refer to that same file using a relative path name, which does not start with a leading slash. Okay, it's relative to whatever directory I happen to be in right now. Okay, so in my home directory, the poker directory, there is a file called dir, or a directory called dir1, and in there there's a file called file1. So if I first log in, I can refer to that file, file1, by either of these two things, right? I can give it the full path name starting with the leading slash, or I can give it a relative path name for what it is after my home directory. Okay, and they're both, those equivalently talk about the same exact file. If I change now into the directory dir1, here are some other ways that I can refer to that same file, right? The absolute path name /home1/class/fall18, whatever, hasn't changed, right? That starts at the beginning and it still points all the way through all of the directories to get to that file. However, if I've now changed into directory dir1, the relative path name pointing at that file is now just file1, right? You know, I don't need the dir1 in front of it because I'm already in dir1. You could also refer to it using that special directory that points to the directory above you, right? So I could say /dir1, so / would point back to the poker home directory, right? /dir1/file1 is the same file. Or I can refer to it with the // file, which the dot is this directory /file1. All of those things, if I've changed into the directory dir1, all of those things are equivalent. Does that make sense? That confuses people sometimes because they'll have no idea where a file is or how they got to it or where, you know, and using that pwd command to figure out what directory you're in can be helpful in terms of figuring out where things are and how to refer to files. In all cases, that absolute path name will always work. Doesn't matter where you've changed directories to, as long as you're on that system, that absolute path name for a given file does not change. Any questions about that? Okay. Some common system directories that you'll run into, there's always the root file system, and that forward leading slash is referred to as the root directory, kind of like the root of a tree, I guess. There's always a /bin directory, which is binary executable files or programs. There's a /dev directory, which is the device special files, like for disks and printers and mice and other things that are attached to the computer. /etc, the etc directory, that's usually where administrative and configuration stuff is, like what the network address of the machine is, who the users are and whether they're allowed to log into it. Printer information about what printers are set up might be in there. There's always usually a /home directory where the user folders, user data space is. There's usually a /lib, which is libraries that are used by multiple programs and languages. Temp is like a temporary space. And there's usually a /usr file system as well. And underneath /user, there's usually also a bin and a lib and including some other stuff. So there's usually a /bin directory with some system executables in it, programs, and then there's a /user/bin. And I've been using Unix for almost 30 years, and I just last night figured out what the difference is between /bin and /userbin. /bin is supposed to have files in it that need to be there if you have to boot up like an emergency mode, and the root file system is the only thing that's mounted. Things that you would typically use for emergency repairs or things that need to be there to do anything at all on the system. And the /user/bin is more user level things that you would use as a user, but they don't necessarily, if they weren't there, if you had to boot up in an emergency, it wouldn't be the end of the world. So that's the difference between those. Slash user slash include is typically where include files are, like C include files or other common included pieces of code. Slash home AOS in this case would be the home directory for the user AOS. We talked about kind of what the home directory structure looks like in here. Typically there's also, it's not always there, and I think on Macs with OS 10 it's not there by default, but there's usually a slash user slash local directory. And then underneath there you'd have a user local bin, a user local lib, a user local include, some of those other common directories. Typically that's software that was installed after the fact. So like if you just go ahead and install Linux from the source, from a CD or whatever, you're gonna have the slash bin and the slash user bin stuff, but the stuff under user local won't be there. That would typically be added by someone at a later date. So if you add on extra software later, it usually goes in there. And I think that historically that's just made it easier for backups. You can back the stuff up that's in user local bin and user local lib, but you don't have to back up the stuff under slash bin or slash user bin typically because it came from the source and you could always just do a reinstall and it would still be there. Any questions on the file system stuff? If you get confused or if something doesn't make sense through your career, let me know. Okay, so we talked about already that Unix is case sensitive, so a lowercase ls is not the same as a capital LS. That matters. When you start a shell, you're going to be presented with something called the prompt. Okay, and the prompt doesn't always look the same, and you can actually modify it to your liking. Typically, if you are using the C shell or the TC shell for your shell, your prompt is going to end with a % sign and a number, and that number will be incremented as you start doing things. And then that number is related to the commands in order in the history that it keeps. Typically, if you log in using the Bourne shell or the K shell or bash, you will have a prompt that ends with a $sign. Again, not always, and you can change that, but that's sort of a quick clue when you first log in. If your prompt ends with a % sign and a number, you're probably using the TC shell or the C shell. If you log in and it's a $sign, you're probably using the Bourne shell or bash. And usually if you're logged in as an administrative user, if you log in as root, or if you use SU command to become root, that $sign will change to a number sign. And again, that's just typically a convention. It's not always like that, but often it is. Typically when you're running commands under Unix, the general syntax is there's going to be a command name, then there's going to be a bunch of flags with a minus sign, and then there's a bunch of arguments which the command will operate on. And we'll talk some examples of that as we continue. Usually as you're typing out, you can use the backspace key to erase characters if you make a mistake and want to correct them. Sometimes, and this happens a lot if you remotely log in from one Unix machine to another, or from a Mac to a Linux machine or the other way around, sometimes you'll hit the backspace key and it won't actually start erasing characters. Instead, it'll start putting weird, goofy looking characters at the end of your command line. And what that means is some systems use the backspace ASCII character code or Unicode code for backspace. Some systems use the delete and they're not the same. So if you're on a system that's expecting a backspace and you type a delete, you're probably going to get a little caret and a question mark sort of looking thing. If you're on a system that expects the delete and you give it a backspace, you'll probably see a little caret and an H. Those are the ASCII codes, the control H and the control question mark are the backspace and the delete codes. So when you first log in, chances are that's not going to happen, it's going to be fine. But if you connect to another machine, it might. There's a real simple way to fix it. You can use the command stty, which sets some terminal attributes. You type stty space erase space, and then whatever key you want to use, typically the backspace key. and then enter, and then from then on, it will change it so that the backspace key sends whatever code the machine is expecting for a backspace, only in that terminal session, right? You'd have to do that actually in your startup files, which we'll talk about later, if you wanted to apply it every time. So if you log in, you change it, you do a bunch of stuff, log out, go home for the weekend, go to a football game, come back on Monday, and log in, it's gonna do the same thing, you have to run that again. Another thing about Unix that's kind of interesting is there are usually online man pages for just about everything, manual pages, right? If you wanna learn how to use any of these commands that I'm talking about tonight, the password command, the list command, the copy command, there's probably a manual page on there that documents how to use that command and all of the different options. Like for example, when we do the file listing command, I'll show you like 2 or 3 different options. There's about 20 or 30 of them that you can use to change how the output of the list command looks. And I'm not gonna go into all 30 of them tonight, but there's a manual page that does. One downside to them is they're kind of written in like geek language. Like if you're kind of geeky and you understand computers really well, they might make sense to you. If computers kind of confuse you and you don't get a lot of the technology or the terminology, they may not make a whole lot of sense because they're written by computer people for computer people. If you're ever reading a man page and it doesn't make sense, I'm happy to translate it into English for you if you'd like, or try to, because I'm kind of geek. So I usually can figure them out. But there is a man page for just about everything. So if you want to understand how to use the password command, you can type man, and man is the command that accesses the manual pages. So you can type man. If you want to learn how to use the manual command, you can type man, and it should give you the manual page on how to use that command. If you want to learn how to use the password command, you can type man, PASSWD, and it'll give you the whole layout of how the password command works and how you use it, and if there's any arguments to it. Sometimes you want to find the manual page for a command, but you don't know the name of the command, which makes it a little hard to get at. There is an option to the man command -K that will search on the descriptions of the manual pages rather than the actual programs themselves. So for example, if you want to find the manual page on a compiler, but you don't know the name of the compiler, you can type man -K compiler, and it'll probably give you, a dozen or so different manual pages for different compilers that it knows about. And then given that list, you can kind of say, oh, here's the C compiler, I want to look at the manual page for this, and then you can get to it that way. So that's pretty cool. Okay, so the way Unix or Linux keeps track of programs that either you are running or other people that are logged onto the machine are running, or that are just running just because it's a Unix system and they have to be running in the background or running for the machine to do anything, every individual program that ever runs is a process, and it's assigned a process ID, which is a unique number for every process. So it starts out at 0. The first thing that runs is the kernel, and that's probably process 1. The kernel does a bunch of stuff. By the time it gets to a login screen, we're probably up in the hundreds. And then when you log in, it's going to run a bunch of stuff. One of those things might be a shell. It's going to have a process ID. Anything that you do in that shell, when it's running, it's going to have a process number. The command to identify and work with processes is the PS command. So if you just type PS in the command window that you might have open on your terminal, it will show you information about the commands that are running in that terminal. There's probably not a whole lot of them. There's probably a shell. There's probably the PS command that you ran to get the information about the PS command. But it's only going to show you the commands that are running in that particular shell. There are some options to the PS command, and again, there's a whole slew of them. You can look at the man page on PS if you want to find out what they are. One useful one is to find out from all of the different terminal windows or all of the things that you have open, what processes are associated with your user ID. What processes are you running? Whether they're in the window that you're typing it from or not. You can type PS -FLU and then your username, and it should show you a whole longer list of processes that are running as your user ID. A lot of them are probably related to the windowing system that you logged in on. Some of them might be things that you ran intentionally. And you can do that for other users as well. If you want to do a PS and find out what somebody else is running, you can do that on their username and see what other people are running as well. If you want to find out all of the processes that are running on the machine, and here's one of those places where, remember when I first started talking tonight, I said there's System 5 and the Berkeley Unix, the two different kinds. This is one of the cases where the arguments to the PS command are different depending on what kind of a machine you're on. If you're on a System 5 machine, and typically most Linux systems these days use this option, the command PS -EFL will give you all information about all the processes that are running on the machine right now. All the processes running by root from when it first booted up, the window manager, all your stuff, anything else anybody else is running. That can be handy if you're running on a machine that's shared by a bunch of people and it's really slow, and you know you're not doing anything on it. We may have run into this in Tristan's group recently. That you can do a PS -EFL and find out information about what everybody's running, and that can give you a clue as to who's hogging all the resources, and you have to go and send a nasty email to saying, hey, kill your jobs, I can't do anything on this machine. If you're on a BSD type system, the similar syntax for the EFL on a System 5 is PS -AUX. That will give you, it'll look a little different, but it'll basically give you the same information about all the processes everybody's running on the machine. And I'll talk a little bit more about the output of those commands in a little bit. Actually, right now, that worked out pretty well. So this is just an example of a PS -FLU on me. Okay, so what processes am I running right now? You'll see a bunch of columns along the top, and unfortunately with this font, it splits into two lines. But this is basically one long line, another long line, another long line. The output here, I honestly don't know what the first character is. The second character has to do with what state it is in the CPU, I think. Don't ever really look at that. The column underneath UID, that'll give you the username of the person that's running it. So in this case, that's me. So if you did a PS -EFL, the person under the UID might be root, or it might be some other user, or you, if you happen to be logged in. So that tells you who's running it. Under the PID remember I said all processes have an individual unique number with them? Under PID is the process ID that the system is using for that individual process. So I've got a process number 1047, process 1049, and process 1048. So that's under the PID. Next to that is a PPID. That's the parent process ID. Okay, in other words, what is the process number of the process that started this one? And you can kind of see a hierarchy here, right? Process 1049, its parent process ID was 1048. 1048's parent process was 1047. And 1047's parent process is 1, which is the kernel that started everything. Right? So you can kind of see how these things all started. This particular thing is actually a MATLAB license manager that happened to be running. There was a shell command that started it. It had some syntax in there, and then it actually had a program that it was running. So that's what those are. The C column has to do with how much of the CPU it's using. That'll usually be a number between 0 and 1, 0 and 100, I think. Or it might be higher than that if you're multi-processing and something's actually using more than one core of a processor to do stuff. PRI has to do with priority. NI has to do with the nice value. It is possible to control how much of the CPU is allocated to a program, and we don't use that. I haven't used that as much recently because processes are so fast now that you don't usually have to worry about limiting access to them for different programs, but that's a way to do that. ADDR has to do with where in the address space of the memory on the computer that process is running. SZ has to do with size. These are all really small processes, but sometimes you'll be running models or things that get pretty big, and those will be in the megabytes or gigabytes. WChan has to do with memory again. The other interesting thing is the S time. That tells you when it was started. So this particular one was started on January 16th at some time. If you're looking at a process that started within the last 24 hours, it'll be a time rather than a date. Let's see, this is how much CPU time I think it's used, and then under CMD is the actual name of the command. So this was been a bourne shell command that ran, this was the license manager thing, and this was a loop within that bourne shell. So that's what the output of the different columns has to do with. You'll probably see something different if you ran that. It can be useful in terms of diagnosing what you're running or what's going on the machine. Any questions on that? Okay. There is another way of accessing process IDs, except not specifically process IDs. Each shell that's running has its own sort of local counter of things that are running in that shell. They're called job IDs. Okay, and if you type job, if you have something running in a window and you type jobs, you may see one or more starting with one and working their way up from there. In this case, job number 1 was running, which is Firefox. The reason it looks like that is you can start the web browser or any program really from the command line. But for something like Firefox, if you start it from the command line, it pops up a web browser, and you do all your stuff in the web browser, and now you got this window that just says Firefox, and you can't do anything in it because it's running Firefox, but you don't actually use that window, right? You don't use the terminal while you're running Firefox. It's possible to put that job in the background, either when you first run it or at a later time, and get access to that terminal again, since other than starting Firefox, you really don't need it. I'll talk a little bit more about how you do that in a bit, but the jobs command is one way of accessing that stuff and changing the status of a job, whether it's running in the foreground, meaning it's connected to the terminal, or whether it's running in the background, which means it's disconnected and you can do other stuff in the terminal. Okay, remember a couple of slides ago when we were looking at the process ID, the PID is the process ID that's associated with that process. If you want to stop a process from running, you can do so with that number and the kill command. Okay, so you can kill whatever that process ID number was, 11, or what was it, 1049 or something like that, and that should kill it. If you want to just pause it, meaning you want it to still be there and available to run, but not actually consuming any CPU, it basically just pauses it, and you can start it up later. You can do a kill minus all capitals STOP, set it a stop signal, and it will cause that program to not use any more CPU until you start it up again. So it's still in memory, it's still, everything's exactly, you could just pick it up where it left off, but it's not currently running. When I was a graduate student and working with Professor Tripoli, we had a machine that we would run operational models on, but we were also running research runs at the same time. And when we were doing an operational run, we basically wanted it to finish as quickly as it could, but we didn't want to have to kill and restart the research runs all the time. So we had schedulers that would send a kill minus stop command to the research run when we wanted to run the operational run. So it would be running along, all of a sudden it would pause, we'd run the operational run, which would go really quick, real time, we're trying to get a forecast. And then when the operational run finished, it would send a continue signal back to that research run and start it up again. That's one type of example of where you might want to do that. For some reason, sometimes when you kill a process, it doesn't actually die. For reasons that are sort of mysterious to me. It might be hung waiting for a disk drive or something weird's going on. If you kill a process and it doesn't die, it sounds morbid, doesn't it? If you kill a process and it doesn't die, you can send it a kill minus 9 signal. A 9, the minus 9, I forget what the signal is, but it's kind of like, all right, I'm not fooling, I really want you to die right now. Sometimes, occasionally, even that won't work, and if that's the case, typically at that point you have to restart the machine, because when you restart, everything dies and it starts totally all over. But so, you can kill a process, if it doesn't die, you can kill minus 9, and that should actually kill it. You can only kill jobs that you own, by the way, unless you're root, right? You couldn't kill one of my jobs, but But if I were root, I could go on, the super user, I could go on and kill one of your jobs, or my job, or anybody's job. So you can see the jobs other people are running, but you can't kill them unless you're root. Okay, so getting back to what I was on the previous slide where I said within a shell, it keeps track of things that are running with a job ID. You can type Control Z to stop a running job. So for example, if you have a terminal window open, you type Firefox, and it pops up a web browser or whatever. In that terminal window, you can type Control Z, and it's basically the same as sending that program a stop signal. It'll basically pause it. Right? If you Control Z it, it stops it. If you go and try and do anything in that Firefox window, it just won't do anything. If you move it around, it won't refresh. It's basically paused. You could type jobs at that point, and you would see something that looked like that. It would say there's a job it actually would probably say stopped Firefox, but there would be a job number one called Firefox. You can bring that job back into the foreground, which means it takes over the terminal again with a foreground command, and then a percent and whatever job number it is. So in that case, you could FG space %1, and it would start Firefox running again and take over the terminal window again. So you still couldn't do anything in the terminal window. I don't know why you'd want to do that, but you could. If the job is stopped and you want to start it up and disconnect it from the terminal so that you get your window back and you can still do things, but Firefox is still running in the background, you can use the BG command, background. Right? If you background %1, that will start it up again in the background. And there's a way to actually start it automatically in the background, and I don't have that right away, but we'll show you when I get to it. We talked about this already. These are just typical places. So there's only certain places on the Unix file system where the shell will actually look for commands to run. Typically they're in /bin, /userbin, /userlocalbin. Sometimes people will have a bin directory in their own home directory that they'll tell the operating system to look in there for programs that they compiled. In this lab, there's a program directory called /research/linux_bin, which is a directory on the server that basically I put stuff in so I can put it on just in one place and it's accessible on all of these machines rather than having to copy it onto all of these machines. And there's an environment variable called path that tells which of these places it looks in for commands. We'll get to that a little later. Right now, the path environment variable is a list of directories where Linux looks for programs. If you're trying to run something and it doesn't appear in one of these directories, it won't find it, even if it's in the directory that you're in, right? If you have a program or a script that should run, it's in the directory that you can see it, it's right here. If it's not in that list of directories that Unix searches for, and you can set that path to whatever you want. If it's not in that path, it won't find it. It'll just say, sorry, command not found. That's where, remember I said, why would you ever want the dot directory? That's where the dot comes in handy. If you put the dot directory in your path, it will look in the directory that you're currently in for programs. For security reasons, it's good to put the dot directory at the end or near the end of your path so that somebody doesn't like trick you into running a system command like list or password. But it runs, instead of using the system one, it uses some bogus one that they put in your home directory that does whatever. It's just security-wise, it's best to have that later in your path. So basically, this is an example path directory. It looks in the grads bin directory, looks in that research Linux bin in here, looks in the IDB, it looks in Macitus. Eventually, it looks in user local bin, user bin, a bunch of different places for programs. If you're using TC shell and you change your path variable, or you add programs to one of these directories, the TC shell keeps a hash table of where all of the programs that it knows about are. If you add a program to one of these directories and you want that shell to be able to find it, you have to type rehash, which basically goes out and looks for wherever there's all programs. That only matters if you want to find it right now. Like if you add a program to a directory, you log out, you log back in, it does that hash thing when you first log in, and so it would do that rehash command automatically. But if you create a program and you want to run it right now, you might have to run rehash. That is not the case in bash. Bash just goes out and looks every time. And here's another instance where you might use that, the dot directory. If you don't have the dot directory in your path, you can tell the system to run a program that's in the current directory by giving it the path name to that, which in this case is / whatever program. And then it'll say, I want you to run, I don't want you to go search through my path, I want you to run this one. Right? If that makes sense. Usually where that will bite people is in our senior classes when you're creating Genpack scripts and you make a program, it's all ready to go, and you make it executable, and then you run it and it says, command not found, because it's not in your path. If you put a / in front of it, it'll run it. A couple of commands that tell you where programs are. There's a where is command and a which command. Sometimes there will be multiple versions of a program in different places in your path. One example that I can think of is Python. Usually Linux systems come with a version of Python installed that's old and doesn't have a whole lot of modules installed with it. So typically people will install either their own version of Python, or they'll use the Anaconda or Miniconda distribution, or an Enthought version. So there's multiple versions of Python out there, and depending on which one it finds first in your path, it's the one that it'll actually use. You can tell which one it's accessing by typing which Python, and it'll tell you which one it's going to use. You could use the where is Python command, and it should go out and find all of the different versions that are available in whatever your path is. And it might find some other stuff too. It might find some manual pages or libraries or things like that. Okay, so you can run several commands on a command line, one after the other, if you want to separate them by a semicolon. So if you want to do a bunch of different things all in a row, you can type ls, which is a file listing command, semicolon, and then date, which is a date command, and you'll see a listing of your files followed by the date. I was talking earlier about pipe, the special files that hold the output of a command as input for another command. That's a vertical bar, so in this case you could take the ls command and do ls minus ltrf gives you a long file listing ordered by reverse time, so the newest ones are at the bottom. And it takes that long listing and it pipes it into a command called tail, which only shows you the last 10 entries of that. So you might have hundreds of files in your home directory. This shows you just the 10 most recent ones. And then, as I was talking about before, in terms of running a command and automatically putting it in the background, for example, Firefox, if you want to run Firefox and have it automatically go into the background without having to stop it and Control-Z and all that stuff, you can just put an ampersand after it, and it'll run in the background. You might end up doing that similarly if you're using Emacs or gedit or some other editor that's like X-Windows based editor, a graphical editor. Same thing, in that you don't need access to that from the terminal once you start it. Yeah?
So let's say you're opening a program with one of those editors, and it's like a specific file that you're opening with, it's like Pluma and the file name. Would you put the and right after Pluma, or would it be after the name of the file?
It would be way at the end of the command.
Way at the end.
Yeah, so it'd be Pluma file name ampersand. Because Pluma file name is actually the command that you're running. Right, Pluma's the program, but then it has options and arguments after it. It would go way at the end of that. And that syntax is also a little bit different between the TC shell and the bash. Actually, I think that part of it is the same. The running in the background is the same. It's if you want to have the output directed into a file that's different. I'll talk about that in a little bit. Any other questions? Okay. Command history. You can type history in C, this will work in bash as well. You can get a list of the previous commands that you've run, and there should be a time on there as well. If you want to repeat the command that you just did, you can type 2 exclamation points in a row, that'll repeat the previous command. If you want to repeat the previous command that starts with some short character string, you can do that. So like if you did an ls command and you want to rerun it, you can type exclamation L, and it should rerun the last command that started with an L, or whatever is enough to be unique. When you do a history, it should have a list of like a numerical list of the commands. You can also rerun a previous command by using the number associated with it. So exclamation 10 would repeat command whatever command 10 was in your history. And then in the C shell, if you want to do a quick substitution of a command you just ran, substituting something for something else, you can type a caret, which is like, what is that, shift 6, caret, and then whatever string you want to replace that's on the old command, and then a caret with what you want to replace it with, and it should run the same command, substituting new where it was with the old command. Just some ways of accessing your command history. In TC shell and in bash, you can also access your history with the arrow keys. If you hit the up arrow, it'll go scrolling back through previous commands. Down arrow will start going back closer to current. And then you can use the left and right arrows to edit the command line when it comes up, so you can basically take a previous command and modify it slightly right on the command line. In the TC shell, a couple of quick shortcuts. If you want to quick jump your cursor to the beginning of the line, you can type Control A, and that will take you to the beginning of the line. Control E will take you to the end of the line. And if you are editing a command, you don't have to move the cursor all the way to the end of the line to run it. The cursor can be in the middle of the line, you hit enter, and it will just run the whole thing. Okay, all commands on Unix, when you run them, have 3 places where they either get data from or send data to. There's standard input, which is usually the keyboard, right? If a program is expecting input from you, the logical place it's going to look is you typing something in on the keyboard. There's what's called standard output, which is usually the screen, right? Or whatever terminal window you happen to be in. If you run a program and it prints something out, it's going to go scrolling up the screen. There's a third place for error messages. So if you run a program and it has some output which wasn't something you told it to output, but like you tried to divide by 0 or called it something that didn't exist or whatever, and it failed and had an error message, that's going to get sent to a place called standard error, which usually is also the screen, right? If you run a program and it has an error, any output or any errors are just going to go to the screen. But they don't have to go to the same place. They're 2 different places, and you can control where those go. You can use the greater than and less than signs to change where the standard input comes from or where the standard output goes to. Okay, so if you want to take the output of a file or of a program and have it sent to a file, instead of going and scrolling up the screen like you got to hand something in, you can run the program and a greater than sign and then a file name. That redirects the standard output into a file instead of going to the screen. Okay, so ls greater than file is going to take my file listing and send it to that file instead of to the screen. A single greater than sign will overwrite file, so file was already there and existed. You're going to overwrite it with whatever the current listing output of that command is. If you want to append instead, if you don't want to overwrite the file, but whatever's in there you want to append to it, you can use 2 greater than signs, and that will redirect your standard output to that file, but it'll append to the end of it rather than overwriting it. Now that's just standard output. That doesn't take the error. Remember I said the output and error are 2 different things. If you want to have the output and any error messages both go to the file, it's a greater than ampersand. So ls greater than ampersand will send the standard output and any errors into a file, overwriting that file if it was already there. And again, 2 greater than signs will append, so that will append any output or errors to a file if it already exists. The less than signs redirect standard input, so if you want to run a command and have it take its input from a file, you would use the less than sign. And 2 less than signs allow you to input, to it takes standard input from the next several lines up until it finds whatever happens to be after it. So where you'll probably run into this, undergrads, is in Genpack scripts. A lot of times they'll have a Genpack program less than EOF or some character string, and then a bunch of things that tell Genpack what to do, and then that word, whatever word is, all by itself at the beginning of a line at the end of it. So it basically says, run this Genpack program, take all its input from the next several lines until you get whatever word is. And it doesn't have to be word, it can be Fred or EOF or whatever. I mean, it just has to be unique, and it has to be the first and only thing on the line. Any questions about that stuff? Okay, so I talked about pipes already. That basically just lets you take the output of one command and use it as input to another. You can roll your own commands with aliases. And I feel like I'm missing a whole chunk out of here. Look, I haven't talked about any real commands yet. We'll figure that out in a minute. If you find yourself running a command that it's a fairly long command and you want to shorten it so you don't have to type the whole thing, you can make your own commands. So in this case, I've got a /bin/ls command with a -ltrf option, and I'm aliasing it so that I can just type ll and it runs that. Similarly, I've got an lt, which basically runs this longer command, piping it into tail. Third example, if you find yourself constantly changing into some long path name, you can make a really short alias. Like in this case, I'm changing into an archive directory. I can alias arch to that, and then all I have to do is type arch, and it'll automatically run that longer command. And typically, these kinds of things you'd end up putting in your startup files, which I'll talk about in a minute, so that they're always there, that they get run every time you log in. The line continuation character, if you've got a really long line and you want to continue it on the next line, it's a backwards slash. And what that actually does is it removes the special meaning of the next character. So like if, I'll talk about it in a bit, but there's an asterisk is a special character that means any characters or 1, 0 or more or anything. If you have a file name that actually has an asterisk in it and you don't want it to be the special character asterisk, you can make it a \\, and it says, all right, it's really a star, not this special character. This is how Professor Morgan deleted his operating system. He says, I've got to tell this story. So he decided one day that he was going to do some cleaning, which is remarkable because he never gets rid of anything. But he wanted to, and maybe this is why, I don't know, he wanted to delete a bunch of stuff. So he wrote a shell script that said /bin/remove -rf, which means recursively, and don't ask me any questions, just do it. And then he intended to have a bunch of subdirectories using a \/ as a line continuation here. So it was a remove and then all these different directories that he wanted to remove. Except he used a / instead of a /. What did that do? It said remove minus recursively and don't ask many questions, starting with the root directory. And so he ran the command, and about 10 minutes later, he's like, boy, that's taking kind of a long time. I wonder what's going on. And he's trying to look at files, and the command wasn't found, and he was trying to check if the job was running, and the command wasn't found. Like, everything was gone. He deleted his operating system. And we had to reinstall it. You don't want to do that. That's another reason you don't want to do stuff as root, because stuff like that can happen. Anyways, that's the line continuation character. It's a backward slash, not a forward slash. Be careful with that. Like that. That's what he was trying to do. But he had a forward slash on there and he got rid of it. Okay, let's see. Shell scripts. You can write a shell script is basically a longer alias. Like if you've got a whole bunch of commands and you want to run them all, but you don't have to type them all in, you can make a script to do that. So for example, here would be a welcome to the morning script. A lot of times you'll use scripts for doing Genpack plots because you can write a pretty complex thing and then you can basically do the same thing but with like a different variable by just changing one line this is the part that I was kind of thinking we had earlier, but we'll talk about some commands and how to work with files and directories. So you can create a file. There's a command called cat, which stands for concatenate. And if you cat a file, basically it's going to take the contents of that file and scroll it up the screen, which I talk about in a few slides. If you redirect the output of that file, of the cat command, into a file, it'll put it into that file. This is just a couple of different ways of taking a number of files and appending them all together. So in the case of the second example here, if you cat file 1, file 2, and file 3 into file 4 using that output redirection, it'll take the contents of the first 3 and append them all into one called file 4. You have to kind of be careful about this because it actually creates the new file before it gets the old one. So that bottom line there, cat file 1 and file 2 into file 1, is going to overwrite the contents of file 1 before they get written into the new file. So you probably not want to do it that way because you just only have the contents of file 2 when you're done. Echo is another command. A lot of times I use echo if I'm writing a shell script to sort of just give output along the way. You know, here I am, I'm running this command. This is another way to create a file. You can echo some text into a file, or you could echo some text and append it to a file. That's usually not how you create files. Usually you create files with an editor, right? You open a file in a text editor and start typing. A text editor is not a word processor. It's not like Microsoft Word or anything. It doesn't have formatting. It doesn't have tables. All it's got is text, which if you're programming, that's pretty much what you want. I talked about it earlier, but VI is an editor, the text editor that's on every Unix system you're ever going to run into. And you would create a file with VI just by typing VI and then a file. If the file is already there, it'll open it in the editor, and if the file isn't there, it'll open an empty file in the editor that you could then save once you're done messing with it. A similar editor, graphical editor that you might use in here is either NEdit or I think gedit is what is in here now. You can NEdit or gedit a file and then put an ampersand after it because it's going to open up a window and then you get your terminal back. Same thing. Here's just a list of some text editors. VI is on pretty much any Unix system you're going to run into. You might sometimes hear it called Vim or VI improved. That's a case where VI was the original editor, but when they wrote the open source version, they added a bunch of capability to it that the original VI didn't have. So if you actually run VI on a Linux system, you're actually running VIM. It's just an alias for it. NEdit and gedit are some graphical editors. Pico or Nano is a character-based text editor. One of the problems with NEdit or gedit is if you don't have X windows, you can't run those. If you're remotely logged into another machine, you might want to use something else. Pico and Nano are something that's a little bit more like maybe Notepad, but in a terminal window rather than a graphical editor. And Emacs, as some of you are already using, it's kind of like VI, kind of has its own syntax. It's very powerful and you can do all kinds of stuff with it. It might be just overkill for just the average user. My voice is going here. Touch is a command that will, yes?
What do you mean by graphical editor?
If you use VI to edit a file, it's going to open that file in the terminal window that you're working in. NEdit or gedit are going to pop up an X Windows thing, which is different from the terminal. It needs X Windows to run. Okay, so touch is a command that will change the modification time of a file if it exists, or it'll create an empty file with the modification time of now if it doesn't. Okay, here's a bunch of commands that will display the contents of a file, like of a text file. Cat will scroll it up the screen. Less will show you a page at a time. More is another pager that will show a page at a time. You can look at it in the text editor. The head command will show by default the first 10 lines of a file. If you just want to look at the very top of a file, you can use head. You can give it a numeric argument that will change how many lines it shows you. And tail does the same thing on the end of a file. So if you want to look at the last 20 lines of a file, you can do tail minus 20 of a file. A lot of times, you'll run a program and redirect its output into a file, and as that file is growing, you can do a tail minus F on the file, and it'll keep scrolling up anything new that gets appended to that file as it goes in there. So if you were running a program and it was adding its output into a file, that would show it to you as it's being added. The list command. List is a useful command because it shows you what files and directories are in the directory that you're in. If you just type ls, it will show you the list of files and directories that are in the directory that you're in, not including the ones that start with a dot because they're hidden. If you do ls minus a, it shows you all of the files, including the hidden files and directories. And by default, the ls command just shows you a list of the files, the names themselves. You can do an ls minus l, that's a lowercase l, not a 1, and it will show you some additional information about the file. It shows you some permission information on the far left, who owns it, the user in the group, the size, the date that it was last modified, and then the file name. And we'll talk about those permissions a little more in a few minutes. Copying, there's a file called CP, which allows you to copy, in the first case file, copy file 1 to file 2. You can copy a file into a directory where it will make a copy of the file with the same name in a directory. You can copy multiple files at a time into a directory. In that case, that last thing has to be a directory. If you try to copy a bunch of files and that last thing is a file name, it'll complain at you and say, sorry, that's not a directory, you can't do that. The move command, it's like a rename command, so you can, if you move file 1 to file 2, it renames it. If you move file 1 to a directory, it physically moves that file inside of the directory, dir1. And again, you can move multiple files. If the last thing on that line is a directory, you can move a bunch of files all at once into a directory. Deleting files, if you want to remove a file, it's the rm command. So rm file 1 will delete it. A lot of times that command is automatically aliased with the -i option, which means interactive, which means it will ask you, are you sure you want to delete these files? There is no recycle bin. I should say, on the desktop, there's a trash can, and if you put stuff in the trash can, it's like Windows or whatever, you can get it back. If you remove a file from the command line, it's gone. You can't get it back. So a lot of times it's useful to use the -i option, so it'll ask you for confirmation so you can say, yes, I really want to delete this file, so you don't accidentally delete something. The -i flag does work with the copy and the move commands too, so you don't accidentally overwrite something. If you try to copy a file or move a file onto a file that already exists, it'll ask you, are you sure you want to do this before you so you can kind of have a little backup in there. The diff command can be useful for comparing two files. If you've got a Genpack script that works, and you copy it, you make some changes, and the new one doesn't work, you can run the diff command to see what's different about them and hopefully figure out what you did to screw it up. So if I've got two files, in this case, line 1 is the same and line 2 is not the same. And in file 2, line 1 is the same, but line 2 is different. And I type diff on those two things, this is the output that I'm going to get. It looks a little cryptic. It's basically telling you to get file 2 to look like file 1, you have to change a line from one thing to another. That can actually be used with the patch command to send out difference files between code for people, but this is, it's useful for being able to just see what's different between files. grep is for searching. If you want to find like what files contain some string or whatever, you can use the grep command to do that. So grab some expression in a bunch of files and it'll return a listing of which files contain that if you want it. By default, it's case sensitive, so if you want it case insensitive, you need the -I option on there. The sort command allows you to sort the contents of a file. That can be kind of useful. You can sort forwards or backwards, or numerically forwards or backwards, or there's a whole other slew of options for the sort command as well. File permissions, remember back a couple slides ago I was talking, the long listing command had this stuff way over on the right, or on the left, RW-. Those are file permissions. And remember when I first came in here and I said there's three kinds of people on Unix? There's you, there's the group that you're in, and there's everybody else. And that's what those permissions have to do with. You can change the permissions on a file. There's a default permission when you first create a file that I talk about, I think, on the next slide. But you can change the permissions on a file with the chmod command. And there's two different ways to do it. You can either do it with user group, other, or all, which is what the U, G, O, and A are. And then a plus or minus to add or remove whatever permission you want to add or remove. And then R, W, and X for read, write, or execute. So chmod U plus X on a file would add execute permission for the user on that file. And if you use A, that means everybody. So where you're going to run into that as a senior, when you create a jump pack script, you have to chmod A plus X or 755 or whatever, however they're telling you to do it. Because typically when you first create a file, it doesn't have execute permission, which means you can't run it as a program. You have to add that permission. Here's the numeric way of using that command. You can give it a number, a 3-digit number, where the first digit is for the user, the second digit is for the group, and the third digit is for everybody else. And that number is the sum of 4 for read permission, 2 for write permission, and 1 for execute permission. So in this case, if I said chmod 761 some file, it's going to change the user permissions to be read, write, and execute, right? 4 plus 2 plus 1 is 7. It's going to change the group permission to read and write, and it's going to change the permission for everybody else who's not you or in your group to just execute only. Now, I don't know why you'd ever do that, but that's what that would end up being. The UMask is a 3-digit number that gets subtracted from 666 for files or 777 for directories to give you the default permission on new files. And typically that is set to 022. If you first just log in, it's typically going to be that. So that any new files that you create, a new file is going to have read and write permission for you and read permission for the group and everybody else, but not write or execute permission for anybody. For directories, it's going to have read, write, and execute permission for you and read and execute permission for everybody else, but not write. So execute permission on a directory means the ability to change into that directory, or the ability to go into that directory. Usually you don't want other people having the right access to your stuff, because then they can delete it, which would be bad. I'm not going to go through all of these. There's some wildcard characters that you can use with any of these commands: list, copy, remove, whatever. If you want to remove everything starting with an A, you can remove A star, where a star matches 0 any characters. A question mark matches exactly 1 character. There's other ways of doing that. Tilde is kind of cool. A tilde will expand automatically your home directory. And if you give a tilde a username, it'll expand to their home directory. So if you wanted to change into my home directory, you could say cd space tilde poker, and you'd change into my home directory. Let's see. File is a program that will tell you what kind of file it is if you're not sure. The find command can be useful for searching. The syntax is a little bit weird, so I'm not going to get too into it, but it's there and I can show you how to use it if you need to do that. If you know you got a file name and it's something.txt, but you don't remember what directory it's in, this is a way to find it. And then a symbolic link is a pointer. I guess I'm not gonna talk really about that except to just say that it's a thing. LPR is the way to print files from the command line, so if you've got a text file, you wanna print it, LPR minus capital P and then the name of the printer, and then the file. Typically, usually you only wanna do that with text files or PostScript files. If you send a binary file like a GIF image, you're just gonna get pages and pages of garbage. Unless most Linux systems are smart enough to recognize, hey, that's an image, I need to convert it somehow, and then they'll send it through some filter and actually print an actual image. LPQ will show you what the Q is. If you try to print something and it doesn't print, you can use LPQ to try to figure out why. If you're in here and you print something and it doesn't print, please let me know because I can probably fix it, and the next student that's in here trying to print something and it actually does print for them will be happy. This is just a list of the printers that are available in here. There's two in the back of this room, GPN and Prism are the black and white color printers in here. Synoptic and Chroma are in room 1443, that's right next to my office. A bunch of files, programs that you can use to compress. Usually people use either gzip and gunzip or bzip. 2 is a newer compression program. Basically you can compress files losslessly so that when you uncompress them you get back exactly what went in, but they're smaller. You can do that to save space. FTP is a program that can be used for moving data from one machine to another. In the early days of the internet, when there were like 5 machines on it, right, when it was like a government thing, everything was sent across the internet in clear text. Passwords, everything, didn't matter. FTP, when you connect to another machine, sends your password across the internet in clear text. Anybody listening in on the line can see it. So you really wouldn't ever want to do that to send real files around anymore. It is still used for anonymous FTP. If somebody puts a file out there and makes it available to anybody, you can log into the machine with the username anonymous, and you just like send it your email address or whatever as a password, and then you can download a file. But in terms of actually like logging into a machine and moving files around, you don't want to do this anymore. Instead, there's a program called SCP, which is called Secure Copy. Once you connect to the remote machine, your password and everything that goes across is encrypted, so you know Joe Hacker can't like see your password going by. The syntax to move files around is SCP, and then the file that you're going from, and then the file that you're going to. So in this case, in the first example, I'm SCPing a file name on the machine that I'm on right now to some remote machine with my username, colon, and then some path to the file name where I want it to go. So I'm basically taking a file that's on the machine I'm logged into and sending it onto a remote machine somewhere. The second example, SCP username at remote to dot, basically does the opposite. It copies a file from some remote machine onto the machine that I'm on right now, putting it in the directory that I'm in, which is the dot directory. Does that make sense? That'll work on Unix or Linux. It also works in the command line on a Mac. If you're on Windows, and you can use asterisks to copy multiple files. Sometimes you need quotes around that to make that work. If you're on a Windows machine, they don't have SCP or SFTP. SFTP is a wrapper around SCP that has syntax like FTP for older people who remember how to use FTP but don't want to figure out how to use SCP. For Windows, there's a program called WinSCP that you can get. There's also a similar program. Remember I was talking earlier about Secure CRT is a secure shell program for Windows that you can get from the Campus Software Library. There's a corresponding program, SecureFX, which is basically a file transfer program. And it looks like Windows Explorer. You just connect to a remote machine and you can drag and drop files from your local machine to the remote machine or vice versa. And again, if you need help setting that up, I can help you. Okay, a bunch of programs that work with directories now instead of files. MKDIR will make a new directory. You can use the move command. the same as you can with a file, you can rename it. But if you do an ls on the directory, it will show you the contents of what's in that directory. If you copy a directory recursively, it's copy -r, directory 1 to directory 2. It'll make a new directory called dir2 and copy all of the files into it. The rmdir command will remove a directory, but it has to be empty. There can't be any files other than the dot and the dot dot that are always there. You can recursively remove a directory and all of the files underneath it with a remove -r. That'll remove a directory and any files. So if you want to remove a directory that already has stuff in it, you can remove -r to get rid of that. PWD we already talked about. Environment variables. So any questions about the commands for working with files and directories? There's other commands, I can't get into all of them, but those are sort of the main ones in terms of listing and creating and copying and deleting and stuff like that. Okay, environment variables are typically used to tell programs where to find stuff or to change their behavior somehow. You can look at the value of an environment variable by echoing a $ variable, whatever the variable name is. In the C shell syntax, you set environment variables with the setenv command, so setenv space, a variable name, and historically they're typically all capital letters. And then whatever the value is. In the bourne shell, you have to set the variable name equals something and then export that variable. In the bash and the K shell, you can do that all in one quick line, so you can export some value, some variable equals a value. If you want to see what environment variables you have set currently, you can type env, and it should show you all of the environment variables that are set. There's going to be a bunch of them and what their values are. Some common ones, there's an environment variable called display, which tells the X Windows programs where to display their output. You might have an editor variable, which is your default text editor for various things. A pager environment variable, typically that's set to more or less, but like if you're doing a man on something, it'll pipe it into whatever pager that defines. Path is an environment variable that has a list of directories where it looks for programs. We talked about that a little bit earlier. You can set a default printer for the LPR command, so you don't have to type -P in a printer. It'll just automatically go to whatever printer is defined. Shell gets set with the name of the shell that you're using. Term gets set with the type of terminal that you're using, and TZ is typically whatever your time zone is. Those are just some common environment variables that are kind of always set. Some other ones that you might run into, netcdf. A lot of times if you're working with programs that use netcdf libraries, this will tell it where to find those. A lot of times there's something called load library path. Sometimes if you've got library files for a compiler or for some other software package that aren't in a normal location, you can add that location to here so that the operating system knows where to look for them. MATLAB path sometimes will tell it where to look for matlab.m files. And if you're using NCAR graphics or NCL, typically you'll have an NCAR-G root path that's set that tells NCAR graphics where it's installed and where the data files installed. In the TC shell, there's another set of environment variables that are called shell variables, and they're typically lowercase. They're different from environment variables. They're sort of local to the TC shell. I've used these because you can do numeric operations on them. So you can like increment them or iterate on them. Again, you can echo $ in the variable name to get their value. The syntax in C shell is set, variable name equals something. If you want to set it as a numeric value instead of a string value, you use the @ sign. So @I = 5 sets I equal to the numeric number 5 rather than the string character value 5. And if you just type set, it will print out the values of all the environment, or all of the shell variables that are set. And those are typically only used in the C shell or the TC shell. In Bash, kind of environment variables and shell variables are used kind of the same. Some startup files. These are basically files that happen every time you log in. So if you're using the C shell, it's gonna execute .cshrc. TC shell typically uses .tcshrc, although it'll sometimes read .cshrc if the TCSHRC doesn't exist. This is where, remember I was talking earlier about you can create aliases and you can set environment variables. A lot of that stuff, if you want it to happen, every time that you log in, it gets put in these startup files. So in the lab here, you're gonna have a file called .tcshrc that has all that stuff in it. Tells it where to find Genpack, tells it to set the path to look for different programs that we have here. You can set aliases in there so that they're always executed when you log in. If you're using Bash, or if you're on a Mac which uses Bash, typically it's .bash_profile is the same equivalent file for Bash. And the syntax between those is different. So here's an example .tcshrc file. This particular one has some, the switch command basically says what operating system am I running. If I'm running IRIX, I do SGI stuff. If I'm running Sun OS, I would do some Sun stuff. If I'm using Linux, I'm gonna do this stuff. I'm gonna set that UMask thing to set my default permissions, set a path, set the nkrg root, some other stuff. So you can take a look at your .tcshrc file if you want and see what's being done in there. Some aliases down there and changing the prompt to do something different. Bunch more commands. I guess I won't go through all of these. They're in the handout. Commands to look at disk space. df is a useful one to find out how much space is available. Script is a nice way. If you type script, it'll create a file called TypeScript that has anything you type and any of the output from it in that file called TypeScript, which is handy for capturing like the output and the commands that you run in the output from them. Connecting to a remote machine, this is the syntax for using SSH or slogin to connect from one Unix machine to another. We talked about that way at the very beginning, and the -X or the -Y to tunnel the X Windows stuff. Then there's a whole bunch of other commands. You can check the man page on these to see how they work. This is a list of various compilers that you might run into. Typically on a Linux machine, the C compiler is GCC. The C++ compiler is G++. There's a whole bunch of Fortran compilers available. G-Fortran is free. We have access to the Intel and the Portland Group compilers here, depending if you're running WARF or something like that. And I can help you with that. So it's just some syntax at the bottom. Some other things, Perl, Python. You might run Python programs or Jupyter Notebook to do stuff inside of a web browser. Make is a way of maintaining programs. If you download stuff off the internet, it might come as source code that you'd have to run, configure, or make to compile it and build it to actually run it. There's a mail program that you can use to send mail if you want to. Usually you're using a web client or phone or whatever, so you probably have to run into that very often. There's various programs that you can use for text processing. In here, XPDF will allow you to read PDF files because I don't think Adobe supports Linux for Acrobat anymore. A bunch of programs that are available for viewing or creating or processing images or loops or animations. FFmpeg is pretty cool if you've got a bunch of images and you want to turn it into a loop like I do with the rooftop camera stuff. Or the satellite loops that I make, a lot of times I use FFmpeg for that. GIMP, I don't think I have that installed in here, but I should. It's an open source program, kind of like Photoshop, that allows you to mess with images and do all kinds of cool stuff with them. VLC is a movie viewer that you can use in here for looking at, again, the rooftop camera video or the satellite animation movies or things like that. Typically, Firefox or Chrome. There's a couple of text-based browsers that are kind of cool. Lynx, Lynx is one of them. Lynx, Links is another. Where I run into that as a web developer is trying to see how things look on like a screen reader for disabled, like if you're if you don't have access to all of the graphics that are typically on a web page, you can see what it would look like to someone who's using a screen reader to read it out. Or if you need to download a file using HTTP and you don't have access to a graphical desktop, you can use these to do that as well. Like graphical, I mean like Firefox or Chrome or something that would actually have what you typically think of as on the web. No Microsoft Internet Explorer, no Edge, no Safari on Linux. Mac would have that, obviously. Bunch of programs that we use for plotting weather, plotting and accessing weather data. You'll run into a lot of these in Synoptic Lab or in your meteorology classes here. Here's a sample Genpack script. If you want to do that, it actually exists. If you copy /research/sample_genpack_script.csh to your home directory, you can run that and it should create an 850 potential temperature and sea level pressure map from today. It's a starting point. You can modify that, or just if you want to see how a script works. You'll probably end up using Python at some point in here. This is just shows you where to get Minicondo, which is a small version of the Anaconda distribution, and some other syntax on how to create environments, which is pretty cool. You do have to use bash with that though, so when you come in here and you open a shell and it starts your tcsh, you have to type bash and it'll start a bash prompt and then you can run the Python stuff. Okay, 5 minutes over, I apologize. Most of the information that I got in here comes from a document that some guy wrote called UNIX is a 4-letter word and VI is a 2-letter abbreviation. That is available, as well as something called Unix Help for Users. A lot of the same information, a lot more information about how to do things, different commands and things like that, available at that URL. There's also information about HTML and Fortran and some other stuff in there as well, so use that as a resource if you'd like. And with that, if you gotta get rolling, that's fine. I can talk about VI if anybody would like to learn about VI. And if not, or if you have any questions about your work that you're doing, let me know. I know I kind of blew through all this stuff really fast. You probably won't remember 90% of it. Refer back to the PowerPoint or come and see me if you need a hand with something. And I hope that was helpful. So, questions?
Are you talking about like the forecast movie thing you have? Not a movie, like it's like really different forecast hours you put up on the weather page. Is that the FFM tag you're talking about? You're talking actual.
I'm talking actual movies like an MP4 file or something. So like the rooftop camera video is a QuickTime movie that I use FFmpeg to make. The stuff where you cycle through it on the web page, that's usually using some sort of web-based animator, either HTML5 or JavaScript as an animator like that. There was, if you go back far enough, you used to use Java, and there was this thing called JS Annie that Tom Whitaker wrote. Then he recast it in Flash, so Flash was sort of the big thing for a while in terms of doing any sort of web-based interactive type stuff. And so that was used for a lot of our model, when you go through the model maps. So that's basically creating those animations in a web browser on the fly from a bunch of static images. FFmpeg, a lot of, I don't know if you've seen, a lot of times they'll put out goes 16 loops of cool stuff and it's an MP4 file or it's up on YouTube or whatever. Those I create using just individual images and telling FFmpeg to assemble them all together into a movie format file, like an MP4 usually. If you're interested in how that works, I can show you how I do it. It's a little more complicated than just a one-line thing, but it's not.
I'm interested in more of the cycling you're looking for.
Yeah, look up I think it's H5 Annie. Does anybody want to hear VI? I mean, I can talk about VI. It's 8 slides worth of stuff. Go if you don't want to. I don't want to. I won't feel bad if you don't want to hear about VI. It's not the end of the world. Let's see. So somewhere in here, I think So www.scc.wisc.edu/HANIS, H-A-N-I-S, allows you to take a file with a list of like GIF images or JPEG images or PNGs and turn them into an animator with controls and stuff like that. That's what I would recommend. There's others out there. Pivotal Weather probably uses something else. I think the stuff that they use at Albany uses a different animator. I don't know what it is, but that's one.